Come and Go Car Company rental charges a base rate of $25.20 a mile. Write an equation to express the relationship between the number of miles driven M and the total cost C. So C is representing our total cost, so I'm going to write C equals. What makes up our total cost? Well, 20 cents a mile, that's our rate. 20 cents per every mile, so that's going to get multiplied by however many miles we drive. And our base rate, or our one-time fee, is $25. It's an additional $25, so I'm going to add it to my equation. Step 2 says state a reasonable domain and range for your equation and situation. So remember, domain is talking about what x can be, and range talks about what y can be. What does domain or x represent in this situation? That's our independent variable. So it's representing the number of miles, M. And our range, y, is representing our total cost. Our total cost depends on how many miles are driven, C. Okay? So first what this is asking is, hey, what can x and y be in the equation? Well, normally x is my independent variable. X could be anything, so we call that all real numbers. And y also could be all real numbers. No matter what value I put in for x, I'm going to get some sort of y value, all real numbers. But in this situation, I can't go negative miles. I can go 0 miles. I can go 1 mile. I can go 2,000 miles. So in this situation, my domain is that M can be 0. So it can be equal to 0, but it could also be anything bigger than 0. And then my cost, if you were to substitute M in, 0 in for M, when we solve it, we would get 25. So my cost could either be $25. I have to pay that no matter what. Or I could pay more than $25. Number 3 says, what is the slope of this line? Our slope is talking about that number that gets multiplied by x, or by m in this situation. My slope is 20 cents per mile, 0.2. Another way I could write that, it says, what is this slope as a fraction? Well, 0.2, another way of saying that is 2/10, which when I simplify that, that would equal 1/5. So what does this slope represent in this situation? This slope represents our rate of cost per each mile. Which in this situation is 20 cents per mile. What is the y-intercept of this line? Remember, the y-intercept is where the line crosses the x-axis. It's also our b in our equation. Our y-intercept is 0. It's a point, 0, 25. What does it represent in this situation? It's our base, or our initial costs. It's our starting value. It's $25 is paid before driving any miles. C says, what is the total cost of driving 200 miles? Well, how would I figure this out? 200 is M, how many miles we're going. So I'm going to substitute 200 in for M. So I have 20 cents multiplied by 200 plus 25. 0.2 times 200 ends up being 40. And 40 plus 25 is 65. So my total cost for driving 200 miles is $65. The next couple questions, number 5 says, Come and Go Car Rental chart changes their base rate to $35. What does this change about the equation or graph? So in my equation, is going to change from adding 25 in the back half to adding 35. So my equation is going to change to 20 cents times m plus 35. That changes my y-intercept. So the y-intercept is now 0, 35. 35. This is going to add $10 to every y value on the graph. So it adds $10 to every y value on the graph or the table. All right. Number 6, it says, if the problem stated that we only had $100 to spend on the car, how would this information change the domain for the situation? So our domain before was that our M could be greater than or equal to 0. Well, if we only have $100 to spend on the car, that's going to change things. So if my total cost C is 100, I'm going to substitute 100 in for C, and I'm going to solve for M. And it said for the original situation, so we just have the 25 back for our y-intercept. So I go to solve, I subtract 25, I get 75 equals 0.20 m, divide by 0.20. 75 divided by 0.20 is that my miles, the maximum amount of miles that I could drive for $100 would be 375 miles. So my domain is going to change to a range. 0 is the smallest my domain can be, and 375 is the biggest. So the way that I would write that is that M is 0 is less than or equal to M, or M is greater than or equal to 0, but M also has to be less than or equal to 375 miles. So the next situation is giving us graphs and asking us to determine some different things from these graphs. It says the graphs below represent the distance traveled by 3 different people. Use the graphs to answer 7 through 9. Graph number 7 says, what is the rate at each person is traveling? Remember, rate is another way of saying, hey, what's the slope? Okay, so we're going to find our slope of these graphs. So I'm going to pick 2 nice points. I'm going to count my rise over my run. Be careful about the intervals on these graphs. Okay, so this first problem, my y value is going from 4 to 16. 4 up to 16 is a change of 12. So we're going up 12 and over 4. Well, x-axis is just counting by ones. So my slope for situation number 1, who is Donna, Donna's slope is m equals 12 divided by 4, which is 3 miles per hour. Our next situation is Jeff. If I pick 2 points on this line, you might already have an idea what the slope is, but I would go up 0 and over 3. My slope is 0 divided by 3. Jeff's rate is 0 miles per hour. Or his slope is 0. And our last person, Paula. Okay, again, I'm going to find 2 nice points. Be careful, again, about the intervals. So my y-axis was counting by 4s, so I actually went down 4, negative 4, and over 1. Negative 4 over 1 simplifies to a slope of negative 4. So Paula's slope is negative 4 miles per hour. Okay, the next set of question 8 says, which person is traveling the fastest, and how do I know? So Paula is actually traveling the fastest. How do I know that? Her slope is the steepest. Her slope is also the biggest number. 4 is bigger than 3, which is bigger than 0. So yes, her slope is negative, but she's still traveling the slowest, or the fastest. Number 9 says, what does the y-intercept in each graph represent? The y-intercept is found, again, right where my line crosses the y-axis. Okay, and when I interpret the graph, if you look up at the top by the y-axis, it says distance from home in miles. So the y-axis is representing the distance each person is from home. And if you think about it, the last question, why Paula's traveling the fastest, 4 miles per hour is faster than 3 miles per hour, which is faster than 0 miles per hour. Paula was just traveling towards home, and Donna was traveling away from home, and Jeff is just staying in one spot. All right, so let's flip over now to the next page. So what I'd like you to do now for this one is I would like you to try to answer things on your own. I'm going to go a little bit faster through things. So try to pause the video, try to answer a couple questions on your own, play the video, and kind of see how you're doing, okay? So number 10 says write an equation for the cost of renting a car through STARS. So STARS slope or rate was 50 cents per mile, and their initial fee was 30. What would my equation be for Stripes? My equation would be 0.20m plus 45. 20 cents per mile and then a 45 initial cost. It says graph these two equations. Make sure you label the graphs. We always label the graphs when we make our own graph. Okay, so we give our graph a little title. You can think of something creative. My title's not super creative. I'm going to call it Comparing Car Rentals. Maybe you said something like Stars versus Stripes, something else. My y-axis is my cost, and that's measured in dollars. And my x-axis is talking about the distance in miles. So in parentheses, I put my labels of what each of my axes are representing. So when we graph this equation, STARS equation would be a y-intercept of 30, so that'd be my first point. And then my slope is 0.5 miles. So basically what I did is I just substituted a nice value in that would work. So if I substitute 25 in for x in that equation, or sorry, 20 in for x, I would get out y being 40, so a point 2040 is on this graph. Okay, another nice point or nice value I could substitute in is the number 40. If I substitute 40 in, I'm going to get 50 for x, so 40, 50 would be another point. Okay, I'm going to make this line purple. Here's our first line. Okay, I wouldn't have an arrow on the left side, but I would have an arrow on the right side showing that graph can keep going on in the, towards the right. My y-intercept for Stripes, I'm going to use boxes this time to represent stripes. So 45 is my y-intercept. If I substitute a number in, if I substitute 25 in to this equation, I would get 50. If I substitute in 50, I would get 55. So 50, 55. 75 would give me 55. 75, 55. And then I can go ahead and make that line. I'll make this line green just so you can kind of see the difference. Of course, I lost my line. There we go. Okay, again, I'm putting an arrow at the end of that line showing that it goes on in that direction. So stars is purple, stripes green. What is the y-intercept for each of these equations? So stars y-intercept is 0.30. Stripes y-intercept is 0.45. What does the y-intercept mean in this situation? It's the initial or the startup cost. Initial / startup cost. Next question says, what does the slope represent in each situation? So stars slope would represent that it's 50 cents per mile, and stripe slope would represent that it's 20 cents per mile. Okay, move on to the next set of questions. So what I would like you to do right now is answer questions 16 through 19. When you're done answering those questions, I want you to press play on the video. So pause it right now, press play, and then check your answers with my answers right after this slide. All right, so here